I didn't see an obvious place that they're being put. Has anyone else seen location of lectures, and have you been being sent email for this class giving the location of the lectures? Okay. That was one of the kind of conditions of recording it, that we'd be able to get those available for students on Moodle. So I'll look into that. I have posted the slides for earlier classes, so you can go check those out. But we'll make sure that the links are up as well. Okay, so last time we had covered a number of additional best practices, and the one I think we finished with was a discussion of continuous integration. And I had noted that continuous integration is one of these practices that offers a variety of benefits within the development process. Can anyone talk a little bit about what's the motivation for, first of all, what is continuous integration? Let's remind the class of this.
It's when you continuously add the new code that's being developed into your old system.
Good. And each time you add that in, what happens in a continuous integration environment? Okay. Yeah, so there's a set of, every time someone checks something in, there's a set of processes that are kicked off at that time. And these processes include testing as one of them. Typically not a full test of the system. In larger scale industrial projects, that's typically not possible because the number of tests involved is too large, and it would mean that it's too burdensome to execute at the time of every check-in. So instead, a subset of tests are run. And one of the most critical of them has a special name to it. Does anyone remember? Smoke test, yeah. Now, most tests aim at giving you a sense of quality problems with your system. They end up helping you try to find defects with your system, among other things. It's hard to describe some of them as defects. Some of the system trouble incidents may be usability issues that it's harder to use the system or it's slow. So to say it's a defect, it's not a bug in sort of a classic sense that we think about it. It's not crashing the system or causing data corruption. But it's a problem. Most tests are geared at trying to discover those. Smoke tests, by contrast, are not. What are smoke tests designed to try to give you? They're trying to give you a sense of basically, is the system in a sane state? Is it at a state which would be acceptable in terms of other people using it within the team? This is very important because if those in the team are seeking to do testing with the system, if they're seeking to do development with the system and to use your recent contributions, your contribution should have left the system in a state that's usable, right? I mean, if your check-ins have wedged the system in a way that no one else could use it, how are they going to be able to test their code against it? How are they going to be able to verify whether their code is even roughly working? Generally speaking, when you do a check-in, you want to be very, very clear that the system's in a highly stable state, a state which is where others will still be able to do their work. So a smoke test is designed to basically do a sanity check of sorts on the quality of the system. Is the quality roughly at a level that would be considered passable for letting others do their work? It's not a full demonstration that it's bug-free by any means. It's a demonstration that it's not so broken that you got to immediately throw it out. Now, typically, beyond the smoke test, there's a set of other tests that are run in an automated fashion. And these will be everything from unit tests to system tests, tests at integration level. But there are typically a subset of all tests because in a traditional project, all tests would be just too burdensome. You want to allow multiple check-ins within quick succession. You don't want each check-in to take 5 minutes of testing. So typically you do a subset of tests along with this. Maybe it's a small set of unit tests. Now, my observation for this class has been that the suites of tests that are seen are smaller than in industrial projects, perhaps by an order of magnitude. And that's not good. It's just an observation. And so in those cases, including within the continuous integration, these additional tests are perfectly possible for many of them. Not for UI testing. UI testing using tools like Selenium for a web-based application, or using a tool like Abbott for UI-based testing, or JRobot, or automation. These are fairly heavier weight testing tools because they go through the UI. They involve the system literally simulating pressing button, going and typing something into a text box, and they're much more burdensome. So you can't run them every check-in. So continuous integration, that's a sense of what it involves. What are the benefits? Why would you do that? Why would you go through this whole process of doing this testing, of compiling the system, of deploying potentially the test servers, of recreating a database? Why would you do that at each check-in? Yeah, exactly. If there's a problem there, you want to know about it as soon as possible. Why? Because if as an old time, so before about the mid-'80s, the general tendency would be that you'd have a bunch of check-ins over time, and then maybe at the end of the week, you do your build. And that was a real problem because, well, at several levels. You try to do your build, and it ain't working in terms of even basic compilation. Even prior to that last day of the week, for example, if people were refreshing their code base based off the contributions of others, their code base may now be corrupted with poor quality check-ins from others. They've refreshed their code against others, and they've gotten things from others which are broken. And it wasn't fully tested in conjunction with the other code. Moreover, if there were bugs found, it wouldn't be clear which check-in led to the bug. You've got 30 check-ins that have gone on during the week. Now you've got a bug in the code that comes from the compilation on Friday. Which check-in was it from? It's not immediately clear. So you have a lot bigger set of possible changes that could have led to that defect. Now, if you do a build after every check-in and you find a problem, like it breaks the smoke test or it breaks some unit tests, you can narrow down the set of changes that may have affected it to a pretty narrow set, the set that were associated with that check-in. And this brings me to my next point, which is you should be doing those check-ins daily or at most every couple of days, so that in logical chunks that work together, that are consistent with each other. Again, you don't do check-ins every time you've just modified something, because it may not be in a consistent state, and you check it in and it doesn't even compile. So you check it in once it's gone. You've verified that it compiles fine. You've run it, a set of basic tests on it. Maybe you've had it peer reviewed. Maybe you've documented it. That is when it's ready for a check-in. Boom, you check it in. And that's still often a quite small set of things that have changed. So if it causes a problem with the smoke test, or if it causes a problem with compilation, or if it causes a problem with some unit tests, you have a small set of possible culprits. The culprits that were checked in that specific instance. Does that make sense? OK. So continuous integration is a tool for helping us find our bugs early and often, much like assertions are at runtime. So the overall idea here is that you have these builds going on. It used to be daily. This is the sync and stabilize process that actually Microsoft invented in the mid-'80s. It was revolutionary because it allowed them to produce software in these quick iterations in a way that was much more nimble, much more agile. And the Excel team at Microsoft was the one that really pioneered this. And I was privileged to be part of that team at that time and to be part of this process. So, within Excel, we do daily builds. At the time, we couldn't do continuous integration because it was too burdensome. And then you do a smoke test associated with that. And generally speaking, there's this rule that developers should fix bugs on existing functionality before proceeding on to implement new functionality. Don't go on and create new functions while there's bugs reported, there's defects reported, problems reported with your existing functionality. And then there's the stabilized process where essentially you'd work towards a milestone every few weeks, for example, through building in additional features and every few weeks there'd be a fully stable, sort of solid piece of software that could be examined by the project manager and judged for feedback, et cetera. So this was kind of an early version of the project. These days, it's continuous integration. And the continuous integration is absolutely central to this. So I'd mentioned last time that there was a variety of systems out there, and this is just a subset of them. Apache Continuum is notable because it has Ant and Maven support, which is provided. But Cruise Control is a very popular system. TeamCity has been used by some teams here, teams externally. Jenkins and Hudson. Jenkins was a fork off of Hudson, I think, after Oracle took Hudson in a direction that the developers were unhappy with. And Team Foundation Server from Microsoft supports this. So typically what you're going to do here, now this is very important at a concrete level, you're going to do a clean build up front. Why a clean build? What do we mean by a clean build?
You delete everything and start again.
Yeah. So do you remember back in 2.14 in makefiles, there was often as part of a makefile this thing we'd say make clean. And what that would involve is actually deleting all these intermediate products like .o files. Sometimes there'll be intermediate products that are .c files that are generated automatically, for example, or .h files generated automatically. You'll see all sorts of things that are generated automatically by processes. And make clean will clean those away. Cleans them off so that you start from a common foundation. Why do you do that? Why would you do that? Why not just start with those things? After all, they're already produced.
Because there's a problem in your makefile, you might use old files which give you really weird errors because you might have changed something but it doesn't actually change in the build program.
Yeah. So things can go wrong. So sort of going at this, Warren? Is it Warren? Yeah. Good. General idea is accurate. Things. You might think you could build on what's there, but sometimes things aren't as they seem. Among other things, I've seen cases where people will manually put .o files in that you think were produced automatically, but they built them on their machine. They said, oh, there was some problem transferring it before. I'll just go put mine there. No harm done. There could have been files that were created there based on older versions of .h or .c files or whatever language, Java files, and that somehow those dependencies were missed in the rebuild. In short, if you don't do a clean, if you don't do a build clean, you may be starting with a set of raw materials in terms of already existing files that are not representative of the current system, the current code base. And while that's acceptable risk for sort of common development on our desktops, if you want to be sure that the system's in a sane state, is in a really solid situation after a check-in, you want to start it from scratch. You want to recreate it all the way so you have a dependable, reproducible result from it. Because that's just the issue. If there's a bunch of files around already, foo.o and bar.o from wherever, you're not sure if you do a build atop of those, and it works fine. Later on, someone may try to produce these from scratch, and then do a build, and it breaks because something went odd about the provenance of these files. They came from somewhere else. Something was quite off. And so it's not a reproducible result, the result of the build. You want the result of the build to be reliable and reproducible, that it indicates the quality of the check-in. So you do a clean build. You clean away all those intermediate things, start from scratch, from basics, and you build up from there. So you then compile it, and this compilation might involve a lot of files. On a real-life project, the Excel project, oh man, it might involve 200 .c files or something like that. These days, there could easily be projects where you have dozens and dozens, if not hundreds, of Java files. And so you do a compilation of those, and often there's many steps in here. Ant files, make files, Maven scripts, all those things can actually be quite complex by what they generate. It's not just compile the source code. It's actually sometimes creating source code, creating contents that are read in as part of the compilation for other types of information, for configuration information. So there's a lot of things that go on here often. And then you may integrate with the database. You may actually go recreate the database for testing. So if you have a database that you're going to use for testing this system, a database of, maybe it's of previously contributed photos for a crowdsourcing site, or maybe for the jewelry database project, it would be a set of example products within the store. If the tests frob that database, if they're inserting things in here, or if they're modifying the contents of the database to say, oh, there's a new product, or this one's been bought and therefore shouldn't be listed before, you want to recreate this from scratch so it's reproducible as well. Run a bunch of tests on it. Run inspections. Perhaps this is in the form of checking test results, making sure they look good, but also potentially things like code style, code for code quality, etc. And then deploy the software. So actually deploy it, for example, for use by the testing group across the system. You don't want to give the testing group the software early on before you're sure it compiles or before it passes the smoke test, for example. You want to give it to them once you're sure this is quality product. It's worth their time to test it. It's not going to be negative value you've delivered because now they can't even run the system. That is the issue. You want to use the test team's time well. You don't want to give them something that they can't even open the first screen of it or something like that. Does that make sense? Okay. So this sort of one-step build, this is key. And I don't know how much this has been pushed on by your courses. I mean, in 2.14, we talked a lot about, make files and so on, and that's good. And the idea was to have, single command builds. That's great. Here we're talking about something, a level of sophistication or two beyond that, in the sense that these are automated builds going on, triggered by check-ins, and that involve a lot of different types of steps, including kicking off tests automatically, and including, potentially deployment, particularly when you're dealing with network-type systems. So here we're talking about a more sophisticated platform, and this would be something like in an Ant script that might indicate these kind of different targets that would be used at the time of a check-in. So you go through these various steps here. Now, what do you think happens, folks, if this breaks? Suppose that the build doesn't work. So let me ask this. Suppose you were all extremely conscientious. Before you did a check-in of any of your code, you refreshed your code base, you got all the recent changes by others, you did compilations, you ran the smoke test on your own machine, you ran unit tests for your areas of the code. Perhaps you, as part of that, recreate the database and test it against that fresh database. Things look good, and you got to check in. Is it possible that when you do check in that the build could break? Give me a scenario where it might break without any fault of your own.
Someone else also contributes something, and then mutual dependency makes breaks somehow.
Bingo. And I alluded to something about this in 2.14 one day. You may not remember, but basically there can be race conditions between people checking things in. I can check in A. My A depends on B. And someone else, and I've made some changes to A, and someone else checks in B at the same time. They've been depending on the old version of A. I check in the new version of A. I'm counting on something with B they've changed. And they do their check-in just after I've refreshed my code in my desktop. So I go to, I'm getting ready to check in my code. I think it's looking good. I do a refresh, an SVN update. I get the recent changes by others. And just after that, while I'm running my tests and doing the compile and all that sort of stuff, they check their stuff in. Then I check my stuff in, boom. It doesn't work with theirs. Perfectly legitimate, but you've broken the build. And it's up to you to fix it. Why is it up to you to fix it, typically? Well, who better to fix it? Because you know what you changed. These are your changes, and between you and the most recent other check-in, B, you should be able to quickly converge on, okay, what needs to change? What needs to be adjusted about this to make it happen? It's not that you've done something terribly morally morally faulted. It's just that faulty. It's just that you've contributed things in a way that did break it, and now you're in the position probably to best contribute to it. The fact is, in this class, folks, that a lot of the times people break the build without being careful. They check something in which they haven't even compiled. Can you believe that? Yeah, it happens. They check in something that hasn't been tested. Could you believe that? Yes, I can believe that. Yes, yes, it happens. Could they check in something which has been tested, but where someone didn't look at the results of that testing? I'll tell you a story. In a classroom not far away, quite a number of years ago. So there was a team that was presenting me the results of their tests. So they had this test suite. They were very proud of the test suite. Very, very proud of it. It was putting their system through a set of tests. The system, incidentally, was a system for reserving books and lockers with CSSS. Okay? So it's designed to help the CSSS, the Computer Science Society, manage its resources well. And they were very, very proud of this test suite because it put the system through its paces. And I think it included system tests as well as others, tests based on use cases. And they checked checked it in. The system seemed to be working okay. And they showed me the results of their tests. And they handed it in as part of their deliverable. And I went through it, and I kept on seeing, test such and such, 3 thumbs up. Test such and such, 3 thumbs up. Success, success, success. And then I actually looked at the log of the tests that they handed in. And for each test, what it actually said was, could not log in. And each time they counted that as a success, because after all, it didn't crash. It couldn't log in to perform the tests. And so each of those 3 thumbs up meant nothing. I mean, it meant that it didn't have authentication to actually log into the system to begin the test. They did not look at the results of the tests as part of this. They had just said, okay, the test ran, didn't crash, success. And it was not a success. They had no confidence that these tests actually would pass. But they had omitted that one step. Do you think that could happen in a company? Yeah, it can happen in a company. There's a lot of wishful thinking about this. Okay, so just in terms of clarification, the developers here are working in their private sandbox. They don't necessarily check in the work daily. You're not expected that you have to. You check in these logical chunks of work that work together to deliver some change to the system. And the important thing is that they be consistent, that they be small pieces of work, and they be cohesive in the sense that they accomplish a small number of things together. In other words, that they're focused in terms of the changes. So you have different SVN updates, or excuse me, different commits for different sort of logical bits of contribution. Now, these developers primarily work against other people's code from the last stable build. So the last time the build worked, you're going to be getting code sort of from that time. If someone breaks the build, you got to roll things back quick. So your reference point is always sort of recent successful check-ins. And this build is built up from scratch. And you're going to be testing your code against these recent check-ins before you check them in, making sure the compilation works. And only after that works, and after you've hit all the main checkboxes, which include compilation, include testing, and this is unit testing and smoke test. You got to run it against the smoke test, because if you don't run it against the smoke test, your unit test may pass, but the system as a whole is hosed. Then you're going to want to further do some work, potentially with getting it peer-reviewed, peer desk check, use of Cloud9, whatever. Get someone to look at this and comment on it. So peer-reviewed. And you may want it documented. And at that point, and in here, before all of this, of course, is refresh or update. So refresh your code base / SVN update. So you get recent changes from people. And at that point, you can check in with some confidence. Without sureness, but confidence. Does that make sense? Yeah, so at that point, check in. Now, you want to be really clear, particularly as a project manager or dev lead. When someone says a task is done, which of these things are done? Is it tested? Is it peer-reviewed? Is it documented? By document, I don't mean anything too onerous. I'm not talking about writing 3 pages on it. I'm talking about at least having, for example, Java docs in place, or at least having some clear commenting that says what the parameters are, what they mean. Having some basic level of understanding that will communicate to someone who's interested in potentially using this, what it does, not all about the how, but and what it depends on, etc. So when you're getting reports of when things are done, have a convention, a clear convention in your project as to what's meant. And I don't particularly care strongly about what that convention is. Maybe peer review is left out of that default step, and that's something that's mentioned separately. That's fine, but you need to have a common understanding of what it means to have things done to the point of check-in. Okay? And I would hope that might include peer review, but I'm not going to be really stickler about that. Yeah, I think you will find that helps raise confidence that the build is going to be stable. But if that's not possible for logistics reasons, that's okay. These other things should be there. Okay. So those are some points of comment. Any comments or questions on this issue? This is a very important central issue about the flow of development. Who gets the result of the continuous integration builds? Well, often the testers do. Generally, you don't want to pass it to your client, because this is kind of it may be a feature is not fully implemented, part of the feature is implemented, part not, and it's a step towards it, but you don't want to pass this outside your group. Okay, what's this build maintenance? What's this notion of someone maintaining the build? Well, it's a significant job. In large projects, it's often a full-time job. In your projects, it won't be, but it's a significant job. Code, maker ant scripts or Maven script development, and often you're creating the smoke test and extending it over time. Now, there was an interesting discussion after class last time. Who's creating the smoke test? Shouldn't that be the testing team? And Well, one thing in your projects, you might want to have one of your testers be the person maintaining the build. Among other things, if builds break, it's an indication often of quality issues in certain times, and that's what the testers need to be very attuned to. Where the code is soft, where it's having problems, where it's very complex, and the build breaks are often an indication of that. So within the context of maintaining the build, what you're talking about is a lot of little bits of work after the initial setup. The initial setup, setting up automated testing using TeamCity or setting up using Continuum, that often requires a little bit of effort as well, a fair bit of effort up front on the infrastructure side. But after that, it's a bigger, that big task is passed, and it's a bunch of smaller assignments. Now, in some companies and some teams, maintaining the build is actually used as kind of a punishment for breaking it. So if you break it, you're the one who has to own it until the next time someone breaks it. So it's kind of used to discourage people, and it gets them very familiar with what the build tests and what it counts on, how it works, how it's supposed to work, which means they're less likely to break it next time, hopefully. So just an idea here. Okay, so I spoke about the smoke test. Not discovering new bugs, but identifying stability problems. Identifying problems that it's a sanity check here. It's kind of a yay or nay, not, oh, there's this particular new bug. Okay. Right. So let's talk a little bit about communication mechanisms. When a build breaks, so this came out horribly. When a build breaks, it's very important that people get notified of this, particularly the build master. Get notified, and the person who did the check-in. You want them to know, oh, I checked this in, now I'm going to go to sleep. Not so soon. It broke the build. You got to roll it back. So different teams use different means of communication here, but the general picture is you want to know about broken builds early. Now, I remember a previous team in this class where it was a very adverse situation. They got into a habit of ignoring broken build messages. And so, one would come and they wouldn't have time to deal with it. And then another would come. And eventually, they ended up turning off the notifications. And so the build notifications there had no meaning, really, in the sense that it wasn't really notifying anyone of it. And they were just constantly dealing with broken builds, which is really not the point. The point is to fly ahead of the plane, to avoid it breaking as a general matter of course, and that when it does fail, it's an exception. It's not the rule. So that's what you try to adhere to. So some comments here. Commit code frequently. Here it says at least once a day. For your situations in a project where you're juggling courses, that's typically not possible. But what you should do once a day is update your code base, SVN update, and get the latest changes from others. So among other things, you don't want to be building your code, designing your code against an understanding that's based on an outdated version of other people's code. You may create a bunch of code and find it has to be thrown away because now the interfaces are different. And so it's in your interest to frequently update, at least once a day, get the new changes from others so that your understanding of what their code provides in terms of services, what it's counting on, is as current as possible. Fix broken builds immediately. Write automated developer tests. You should have unit tests which can be automated and run directly when you do builds on your machine, and then shared with the testing team, and possibly early on run in the context of continuous integration. And all tests and inspections should pass. It should be a very reliable thing that you are passing tests once you're done with the coding. What happens early with test-driven development? What happens in the first stages? Do all the tests pass? No. You write the test first, and the tests fail. They should fail. Why would you want a test to fail? Otherwise, it's not testing anything significant. I mean, if it runs and passes up front, why is this code needed? There's something, you're not testing anything meaningful. And so folks, your tests, when you do test-driven development, you write your tests first. They should all fail. Then you write your code. Test should succeed. And then what do? You can write more tests. That's a big part of it. And refine the code. We call it refactor the code. What does refactoring code mean?
It's when you tweak the code to make it clearer or just improve it generally without changing the results.
Yeah, you're not changing the functionality of the code. You're not changing what it does, but you're improving it. Code quality is a lot of it. Cleaner, more transparent, more concise, more elegant, more flexible, more general. There's these various desiderata, higher performance, more robust, but you're not changing what it does. Okay, so refactoring, and when you do refactoring, of course, it's a tremendous help to have those tests. Because if the tests ran before refactoring, they should run after refactoring, because you haven't changed anything in terms of the functionality. Does that make sense? Okay, so getting those tests in place, they should fail at first, okay? And please do private builds. You know, in other words, before you check your code in, run the basic build that's used here, including the smoke test, on your own machine with the latest version of other people's contributions, and make sure it works properly. And if a build has failed, you want to know about it as soon as possible so that you don't get the broken code. If you refresh your code against code that broke the build, chances are you won't be able to build on your own machine or run the smoke test. When I'm talking building and running a smoke test. Okay, so that's good. Database integration. A lot of your code bases, maybe both of your code bases for this term, are going to have databases as part of it. Guess what, folks? We didn't deal with this in 2.14. Probably didn't deal with it in 3.32. You may not have dealt with it in 3.70. But guess what? Databases are now part of your development environment. What do I mean by that? So what? They're part of the development environment. What's the impact of that on this whole picture? What does it matter? Yeah, so the correctness of the code and its ability to run properly depends on the database. And what in the database, in part? Contents, and the contents of the database in terms of data to some degree, but especially the schema of the database. If the schema of the database evolves in a way that's inconsistent with the code, what could happen? So the code's counting on a field called, you know, phone number, and now it's been changed to home phone, or something like that. What could happen to that code? Could that change, break the code? Yeah. So if you don't have something about the database schema incorporated in your check-ins, you're missing a big part of the puzzle, because that could be a really important factor in whether this code passes the smoke test, right? If you're running new code against an old database schema, then maybe it won't work. If you're running existing code against a new database schema, you might, and that hasn't been checked in as part of continuous integration. If that database hasn't been updated as part of the check-in, as a component of the check-in, then you may miss that fact. The smoke test says 3 thumbs up. But when you actually go to give it to the testers, they say, this doesn't work. It doesn't work at all. It's hosed because it's working against this database schema, which is inconsistent. So guess what, folks? Database schemas are part of the development deliverables and need to be checked in as well. And generally, that means the database has to be rebuilt from scratch, because you've got to impose this schema that's on it. Does that make sense? If you make a bunch of changes to your code, often there will be changes to the database schema that accompany them. Not always. And you've got to keep those in sync, and so it needs to be part of the check-in and part of that whole process of being consistent. So you need to automate the database integration. Rebuild your database and insert test data as part of your daily build. Part of your automated build, your continuous integration. Or else you may be missing something. And you'll want a local database sandbox where you can play with a local database without stomping on everyone else's database. So if you're making some changes to certain parts of the code that involve database changes, you don't want to be stomping on other people's databases that they're counting on against older code. In other words, if you're updating the code to use, home phone, and other people are using the older versions of your code because you haven't checked your code in, which is using phone number as the field name, and you go and you pounce on a global database and make that change, suddenly their version of the code won't work. So you need a kind of local database sandbox where you can play with this new schema and not reveal it to the world until it's good and ready. And then you check it in with all your changes that are consistent with it. Make sense? Okay. So here, use a version control repository to share your database access, your database assets. And this may mean scripts in there, too. Scripts to put in data into the database, to insert this data so it can be built from ground up. Okay? And the DBA here, the database administrator, is part of the development team, and you want to give the developers capacity to modify the database that are in a way that allows them to sort of modify the scripts and so on, and to commit them to the version control repository. Okay, so that's good. Database integration is part of the game, and generally in this class, teams have done it not so well, and it's led to discoordination. It's led to one person, for example, being unable to work because another one has changed the database out from under them. And now they have to stop their work and wait for that code of the other person to be checked in to be able to use the database again. You don't want that. You don't want that. You want a more sane process than that. That way, as they said in King Lear, lies madness. Okay? Okay. Any questions about that whole issue of continuous integration? So again, just going back, I hope you'll get the picture here. This is an articulated process. And you may want other steps in here that are not shown right now. You may want a step where there's very explicitly checking of code style. There's steps where perhaps it produces some additional intermediate products. Steps where it pushes it to database, to DMZ servers for access to folks in a special zone with certain security requirements. There's a lot of different changes which might take place on a project-by-project basis. Let me ask you this. For those who are working, well, both the systems we're talking about this year involve mobile technologies and a web-based server. How might this process be informed by that? The fact that we have these web assets and these assets on the phones. How might this process differ in that regard?
You have to run a build that actually runs on a phone first.
Yeah, so it has to update assets in the way that are consistent on both sides. So you've got one on the phone, and then it's got to make some changes often on the server side to be consistent, right? Because now it's the phone software that may be counting on a certain type of information or a certain type of schema in the database. And so you need to keep those two in sync, which probably means that some components of this process are split between or exist in two different forms on two sides of the wire, so to speak, both on the server side and on the Android side, for example, on the phone itself. Or more likely, it's desktop server, where the desktop pushes it to the phone. Right? It pushes the new version of the software to the phone, and it pushes something to the server that's consistent with it. So you have to be a little bit careful with that. Another thing is with mobile devices, a lot of these tests that are run in the server, for example, as a result of a check-in, how are those going to occur? Emulation, yeah. Typically, it's not going to be, you have a farm of phones all plugged in, which are which are all running it. Instead, it's going to be run in an emulator if possible. And so there's some challenges with this. Emulation is slow, and it is hard to do emulation for certain types of components. So, there may be certain tests that are a lot more difficult to run. And this is one of the reasons, I expect to be talking with you all through the term to consult on these issues, talk about how to handle it, talk about resources that might be brought to bear from elsewhere in the department to help make some of these things possible. So this is not a small issue, but it's an issue that affects your work day to day to day, and it pays to get it in a reasonably sane state rather than to sort of flop around. If you don't have a process like this, you'll be potentially working at cross purposes all across the team, stomping on each other's stuff, unable to run your latest check-ins from someone else, and generally unable to make progress until someone else checks in. It's bad news. Okay, so I do want to highlight this factor of directed triage. You'll soon be experiencing it, particularly those who are dev leads, testing leads, and project managers within this group. It's this notion of directed triage. I noted it before. The idea here, folks, is that hopefully throughout the term, per the syllabus, you'll be using tools like Jira, Redmine, Track, GitHub's built-in issue tracking, Bugzilla, to track defect reports, STIs, system trouble incidents, throughout the course of the term, to assign them to people, to make sure they get handled in a timely fashion, et cetera. And that's all well and good, but as deadlines approach, like deadline for deliverable, you're going to have a set of issues in that database which are of all different sorts. Some are recent reports, which could be duplicates of old ones. Some are reports which might have been written against an outdated version of the software, which are still in there, but bugs that have been fixed already. Some of these reports may be reports that are incomplete and you can't interpret them. Others are valid, but they're really unimportant things, and others are really, really important. Could you understand that? So you might have 100. So teams in this class might have had 100 of these in the past at any one time. Open bugs, open potential defects, I should say, open STIs. And as a deadline approaches, you want to know what you're dealing with. I mean, how good a situation are we in? You'll hear something from your team members. Oh, it's pretty stable. It looks pretty good, but there's this bug here. And a big process of, or big important step in knowing where you're at is to actually go through a lot of those reports and say, okay, look, is this real? Is this something serious? Is it a minor thing? Let's take a look through here. Let's see what open ones there are that are potential showstoppers, that can embarrass us in a demo, that could be a real problem in terms of delivering value to the client. Are there things in here which will make us say, okay, hold the presses, let's not roll this certain feature out as planned for this next release. It's too risky. It's too problematic. It won't work. So typically, there's lack of full information here. People on your team won't be available. Someone who had the understanding dropped the course. The report was filed a long time ago, and the person doesn't know if it's fixed. And if you wade through these things, these reports, they can let you figure out, okay, what critical information do I need to go forward? For example, do we have to test the system to see if this bug is still there? And secondly, they can help you figure out, okay, are we at a good enough state to roll it out, or is it too risky? So directed triage, this process of deliberately wading through the bugs, wading through the reports. It's not bugs. I have to be very careful. Wading through STIs, which sounds unseemly, in order to identify the current state of the project. You know, what's our current situation more effectively? This is called directed triage. And it's typically the job of those in those lead positions, dev, team, or dev, test, and in project manager. Test lead, dev lead, and project manager. So this is a very important process towards the end. Okay, so what do I expect here? One or more build masters, one-step builds, from clean slate. I'd suggested Ant here, but that's an outdated reference. Maven is great. Some of you may want to work with Gradle or may want to work with other build management systems which are more modern. Ant is kind of the old reliable for Java. Adherence to some sort of check-in schedule. You know, if you're a project manager, or if you're a risk officer, if you're the one monitoring the risks, you should be very attuned to the issue of, you know, are there certain people who haven't checked anything in a week, in 2 weeks? What would a not so bad situation be if they haven't checked in a week? What would be a scenario which is not too worrisome?
If they're more on the dev team where they wouldn't be expected to develop all the time?
If they're not on the dev team, for example? Yeah, good. That's right. A full-time tester, it's sort of not a problem. How about another one? Suppose they are a dev. So they haven't checked in for a week. Why could that not be a huge problem? It may be regrettable, but why is it not a huge problem? If they're not working on something, they've just been overloaded with other classes, right? And it's not great. You would like to have contributed something, but it's not bad. What's a bad situation? Working on a huge check-in that may conflict with a lot of other check-ins that have been made since then. And when they check in this bolus, it breaks a lot of things. They're just sitting on this, and there's risks there. The risk there is it may conflict with a lot of other changes that have gone on since. Could that happen? You think their change could conflict? Yeah. They started with a version of the code base as of 2 weeks ago, maybe, and now they've made a bunch of changes. Meanwhile, it's changed out from under them. What was one class is now refactored into 2. They go to check their thing, and there's not that one class anymore, and it's not working well. Or it could be that they go to check it in, and it's got a lot of outdated assumptions about how the system works and the functionality of it. In any case, it can cause big problems. So you should have one-step builds on your systems. I will be shocked. I will be shocked if people are doing Java C from the command line. That will be deeply disturbing to me. Please tell me if you are, because I got to help you. But don't hide it. But I will be unsettled. So you want to do a regular check-in schedule, please refresh daily or near daily. Get the latest changes from others so you're not working against old, outdated stuff. And please do that and go through these processes before you check in. You should be monitoring the build status, paying attention to things about broken builds. You do not want to do a refresh while the build is still broken, because you'll be getting broken code, inconsistent code from others. You might want to have different debug and release versions. Why is that?
I want to just have a stable version just to play around with that we know is going to work, not to be quarterly.
Yeah. Having a good stable version, this is something the testers will often do, and so it's a particular note here. So often the testers will not take the latest build, even though it's a sane build. They don't take that. What they do is they take a build that's at a point where it's agreed it's pretty good quality. It's kind of reached a milestone. That's when testers take it, so they can really go to town on it without having lots of things go wrong and distract them, lots of things that would have been fixed the next day anyway. So you often the testers will get a stable build that had reached agreement from the dev team, like this is a good one, go for it. And that's often not every check-in. Every check-in, there might still be things that they're trying to prove. Oh yeah, this is still kind of slow. We got to speed that up, and that's something we'll do in the next few days. So that's good. Debug and release versions may have different policies with respect to assertions being enabled. So debug version may be a lot slower because it's checking a lot of assertion things. It's logging a lot of information. May I suggest to you think for your mobile devices, you think about automated reporting of errors, sending off errors to an error server so that when a crash occurs or when a assertion is failed or when otherwise an exception is launched, it reports back to the mothership and it says, you know, this has happened, gives a stack trace so you're aware of that. That would be in a debug version. It might be in a release version, be in a debug version. But debug versions might be logging a lot of information, et cetera. So automated smoke test, I want to see this in place. Posting and monitoring of smoke test results, and accountability for those who break the build. You know, make sure that you can call on people after they've built the build, broken the build to do it. Well, I think I will. This is just to emphasize this issue of these types of task progress. You want clear, and this is what we call binary mini milestones. When you have an item, you know, implement the expert, you know, the expert opinion needed flag on a given incident within geo crowdsourcing. That if that's checked, all of the requisite things are checked. You want to be very, very clear on that so you don't have a lot of half-done things you don't really know, is it done, is it not done, etc. So that's good. Later in the class, we'll be talking about some things that are really good reporting metrics, and I love seeing these things. Prioritize defect counts, how many type 1, type 2, type 3 defects are in terms of priorities. The number of completed work items, what fraction of them are complete, the amount of time spent working on the items. I like to know how people are spending time. The total number of defects in the repository, the number of defects that have been marked as fixed, perhaps closed or resolved, and then sort of the number of incoming bugs, for example, that have been reported in the last week, and how many have been reported as put aside in the last week as not being fixed. Active time is an interesting one. We'll be talking about this at a later lecture. How long it is from when the bug is promoted to be viewed as a real defect. This is a defect that's substantive. It's not merely a duplicate. It's not merely an outdated one. It's a real issue to the time when it's resolved. That's called an active defect. And how long was it active before it was resolved? That gives an indication of kind of the turnaround time for fixing these things. How many bugs per developer? And this fault feedback ratio was tougher to measure, but it's how many new defects get introduced for every one that's fixed. So I would like to see a collection of some sort of basic metrics like these, like some of these, and clearly documented binary mini milestones, tasks, basically, tasks for your project. Okay? Now, I had asked you folks last time, I don't know if you acted on it, I hope you did, to list out some risks for your projects. Remember that? Okay, so does anyone want to start going through some lists and I could provide some feedback? Better now than later. Better late than never. Better Nate than lever. So anyone want to start going through a list here?
Yeah, I'll just look it up on our wiki.
Good. This will be helpful for the other teams as well.
So I had sickness, like the ID was sickness, the exposure is medium to high.
Okay.
The handling would be pair programming, have several members familiar with each part of the project.
Good. And if I could, in terms of familiarity, one thing you could do is also have shadowing, because pair programming is great for devs, for example, but there's also pair testing, so people are familiar with strategies for testing, and often you get back and forth between the two that you get better testing by sharing ideas. But then there's also the whole idea of shadowing people. So if someone's a build manager, for example, someone else shadows them during a couple sessions, so they see actually how they're accomplishing these tasks, and they can learn some of where things live, how it basically works, what things you have to do for configuring it, where the smoke test source code is located in the repository, what have you. So shadowing is also a really important thing that can help lessen risks and exposure to that. Okay, so good. Another one?
Large volume of homework midterms due in the same time frame as a deliverable.
Yes.
Exposure was high.
Yeah.
Handling regular mini milestones set for ourselves outside of due dates, so we have progress.
That's good. I mean, a key thing there is lead time. So some types of risks can be lessened, not eliminated, but lessened by proactive sort of steps well ahead of time. And this is one of them, because you should have some indications from the syllabus for other courses as to when the midterm exams are, when major deliverables are due, et cetera. And you should be able to compare it to the deliverables for this class now, actually. And from that, you should be able to figure out, okay, who is affected by this? Could subset of the team take the lead for that deliverable, or could you front load the work for the others, right? So some of them may be less affected than others, but those who are affected, I like the idea of having milestones earlier in the deliverable. You'll just want to coordinate that so everyone is clear on that earlier date, so it's not a one-off thing where you mention it to one person in your group. Instead, it's shared knowledge. Good. Okay, others?
Client changing scope of project.
Yeah.
Which, you're the client, so we said that was low to medium.
Okay.
And we said...
I'm not that mean. Yeah.
The handling was flexible code-based design to evolve over time. So as the requirements and technology change, we'll be able to...
Okay. So let's talk about that a bit. So probably one reason you chose me as a client is because I understand some of these risks, and no, I mean, I would have no intention of doing that, and typically I try to shield students from it. And so that's good, but in terms of other teams, like with Daniel Fuller, for Dr. Fuller, he's not a software developer, so there is perhaps more risk there. But one thing that you could do on either project is you have what's called a change control process. This is one of my lessons early on when I was doing software development in a professional capacity. There was one case where we had founded a company, and I was supporting clients. And the clients would call me up on the phone, right? I'd be talking to them on the horn, and we'd be working through their issues and getting fixes out, et cetera. And one of the real problems that came about there was that sometimes the clients really like working with you. And so guess what happens? Who do they ask for the changes? You. Yeah, they ask you. They don't want to go through the project manager. That guy who's always saying no and is saying they're going to charge for it. No, let's just ask the developer. Could you put in? Could you just fix this thing for me? Could you do this, do that? And in this particular contract, I remember it got really bad. This guy kept on calling me up and saying, I want this change and so on. And I talked with our project manager, and he said, look, when that happens, you say, look, there's many implications for this. I don't know all the implications for this, because this involves other parts of the project, other requests from elsewhere in your project. I don't know the financial side. I don't know the time side. You need to speak with the project manager. That's not my job. And what he said is, your job as a developer is to actually work with the client and make sure that they feel they're getting good service and so on. If you start getting in the way of saying, no, we can't do this, or we're going to charge you a bundle for this, that interferes with that relationship with the client, which he said is very important for you to maintain. Instead, it's his job as project manager to be kind of the heavy and say, look, this is not possible, or look, this is the 5th request we've had from within the project within the past month, And the person who's asking me doesn't even know that, perhaps. They just want their change done, but maybe all throughout their other organization they're asking other things. And it's the project manager who sees all those requests, who understands the financial situation of the project, understands the timelines, understands what they're hearing from the top of the other project, not just from the rank and file folks, and can really give that strategic understanding of how do we respond to this. It should not be to you. So in other words, for change control, it's very important to have a process, and the process should go through the PM, and it should involve documentation of the requested change and some process of examining it and giving a formal answer. So change control processes. And in certain areas, particularly certain types of software development, these are absolutely key. Absolutely key. Another area is construction, incidentally. Often you get dinged for the changes. So I'd say having some sort of change control mechanism where if you get a request like this, you know how it's to be routed, how it's to be handled. You can give the client a comment to that effect. That's also something that's quite important. So remember that for the other project. One of the most important things that can derail a project is these requests in the middle of the time. You've gone this direction, now they want you to go this other direction. And it often happens once they see product. Okay, so other ones. These are great.
GitHub branching and merging from different operating systems, like the Macs and Windows. They generally, like, we have the exposure as high, and like the handling of the entire group becoming proficient with GitHub, shared knowledge of their logical nuances brought up both by committing from different operating systems. Example, in my past web programming project, the Macs and the Windows had different default settings for the Apache servers.
Yeah.
So every time we did a commit, it changed the default on the other person's thing, and we just had to rebuild the entire thing. We couldn't figure out what was going on until we just did some git ignore files. But
right.
Stuff like that.
So that's a great example. I think you'll also find resources online for some of those things. And do remember there's many forums where you can often ask questions, and within a few days you might get a response from people with a lot of experience with this issue. And again, if you have lead time, there's a huge number of things in life, folks, that if you have almost no time to resolve it, it's incredibly expensive, problematic, risky, difficult, painful to resolve it. But if you have a few days of lead time, it's much easier. It takes far less work. Believe me, there's a lot of things in life of that sort. You pay through the nose if the deadline is close. And this is an example of that. I think it's a great thing. I love it that you've included in your risk management. And I know in some of our work we've encountered some issues with Mac and PC differences, with carriage return and line feed issues, among other things, interfering with Android scripts, what scripts are deployment on Android, and then batch files versus bash files and so on. So good you're thinking about this early. I would suggest that you tap into the wisdom of folks on the net as well for some things. But flying ahead of that plane is really good before you get knee-deep in all the commits. So excellent. I love it. Other things?
Versioning issues on Android devices, especially for ours because we are building an app. It's low to medium because like there's some functionality that's built into the newer, like say, Lollipop or whatever that wasn't on Jelly Bean. And so
Totally.
if we're using that code and trying to run it on Jelly Bean, it's not right.
Yeah, you have to be really careful about that. I'll tell you an example about a system that we had deployed so it was in the field. This was, our system was, I think, on about 120 people's different phones. And every time it triggered a survey, it would have a certain tune played. So it would play a little tune to indicate that a survey needed to be responded to on the phone, right? And what ended up happening is that one of the people in the study, one of the people carrying these phones, got a notice that a newer version of Android was available. I think this was like, I don't know, 4.1 to 4.11, or it was a very small thing. Or maybe it was 4.1 to 4.2. In any case, they did an upgrade of it. It would have been a minor change, and it totally broke the system because now the location of the tones on the phone was different, and it couldn't find this tone, and it hosed the system, and we had to go redeploy to that particular phone. So that's a minor version release difference. And between major Android versions, there can be much bigger differences. So I agree totally, and I would suggest that you have a standard version that you view as your kind of reference version for the course of the semester, and you just say, we will support this version alone. And if you have time at the end of the semester, you could broaden that. But I think you want to be quite specific about the versioning because this is a known significant vulnerability. You might also think about a very specific subset of devices because there's also Android varies from device to device in some minor ways that can get in the way for certain types of functionality.
And the newer versions should support all the older version stuff, right? They should.
No.
Really?
Like the newer versions have like different features,
Okay.
and so like if you're building like something for Android, you pick like the version what you're doing, and the older you go back, the more devices you'll support. But if you could pick like the latest Android version, and your program would only work for that.
Yeah, no, but what I'm saying is
Backwards compatibility?
If I made something for Jelly Bean, Lollipop, and Kit Kat should be able to run it, right?
Sometimes functions get depreciated, so you try to call some things that exist anymore. Yeah, like if the SU decision back when, and they finally decided, okay, we can actually take it out of our code base now.
Yeah.
It still runs those deprecated code. Well, I mean, you know about Windows 10, right? You know why there's not a Windows 9, right? Because everybody looks at the first digit of your code, and it's 9, they assume it's 95 and 98. Why Windows 9 is not a thing, is Windows 8 and Windows 10. Because everybody got lazy and said, if it starts with a 9, it's 95 or 98, we got this. They found out there was a very, very scary amount of programs that did this. So they simply cannot finish Windows 9.
That's horrible. Don't give me code like that, please. It's a 9. Great. Okay, so those are good. I love to. Remind me your name.
John.
John?
John Mason.
Yeah, John Mason. So did anyone else also bring risks?
Oh, we just kind of,
Okay.
So for our group, we have like the same ones, like time constraints,
Yeah.
and changing requirements.
Yeah.
Those ones. We said selecting appropriate language and frameworks.
Mm-hmm.
We talked about this a lot in our group, and we're trying to like figure out which would be like the best way to like set up like our whole system.
Okay, so that's a pretty expansive one, and you might consider unpacking it into particular risks within that. For example, there'll be some risks that are associated with that. So I like the general category, but there'll be some risks that are like only one person in the team knows this technology, and therefore it depends a lot on that person being available, and being still in the class, all those sort of things. But then there's some other problems which are rather different in that, which is the technology is flaky, or it doesn't support the version of Android that we're depending on, or that it's incompatible with our the other technology we're